This diagram illustrates the historical operating standard for procurement engineers. Optimizing global fastener sourcing has historically been a balancing act of three variables: keeping costs low, ensuring immediate availability, and maintaining strict performance standards. This optimization model functioned reliably because it relied on the assumption of frictionless borders. For decades, moving low-volume goods across international lines incurred almost zero administrative drag. Supply chain strategies could safely ignore customs scrutiny when sourcing these components. Because the physical parts carried a low dollar value, they were essentially economically invisible to border agencies. That invisibility is gone. A sudden shift in U.S. trade policy has injected a volatile, unpredictable fourth variable into the procurement equation: immediate compliance risk. The regulatory shield that previously protected small batch orders and urgent prototype runs vanished almost overnight. The core reality of modern procurement is that a low physical value no longer equates to a low compliance risk. Continuing to operate with a psychological blind spot, treating simple fasteners as risk-free commodities, will now actively erode project margins before the parts even reach the assembly line. To understand the math behind this margin erosion, we have to look at the de minimis exemption. This is a specific U.S. trade provision that historically allowed imports valued under $800 to bypass duty taxes entirely. The exemption enabled high-velocity logistics. Urgent engineering replacement parts and just-in-time prototype shipments could speed through ports without stopping to pay duties. These low-volume shipments easily avoided the heavy administrative friction and extensive paperwork required for standard customs processing. Now, with the exemption suspended and under intense legal review, this frictionless logistical fast lane is completely closed. The operational impact is immediate. Those identical small batch shipments are suddenly forced into rigid, aggressive tariff matrices at the border. This bar chart represents the landed cost for a single small box of fasteners. The base cost is minimal, but when the new tariff is applied, the total cost instantly inflates, sometimes by over 50% depending on origin. This sudden cost inflation destroys the procurement agility required for modern manufacturing, as buyers face intense pressure to consolidate orders to justify the inbound shipping expenses. By removing the exemption, the policy shift transforms just-in-time inventory models from a competitive advantage into a direct, measurable financial liability. The most severe financial drain occurs in an often ignored workflow: reverse logistics. This is the process of moving goods backward through the supply chain, typically for returns, repairs, or replacements. In the fastener industry, these returns are triggered frequently by failed quality inspections, incorrect thread specs, or simply excess inventory generated by project changes. Prior to the policy shift, moving defective or excess parts back across international borders carried negligible cost penalties due to their low value. The current reality introduces a compounding double tax. Tariffs aggressively tax the initial inbound shipment and then tax the outbound replacement parts required to fix the error. This specific double tax breaks the financial viability of existing warranty and service models. The cost to replace a cheap part now exceeds the value of the part itself. This adds severe friction to zero-tolerance industries like aerospace and automotive, where material precision and strict compliance are non-negotiable requirements for safety. Supply chain managers can no longer afford to source replacement parts internationally without running precise, severe cost forecasting models first. Global sourcing is only cost-effective when logistics are predictable. Today, a simple box of replacement screws, held up by complex customs duties, will financially bottleneck a multi-million-dollar assembly line. The greatest vulnerability for procurement teams is the persistent assumption that fasteners are simple, homogeneous bulk commodities. U.S. Customs and border agencies do not view them that way. To a regulatory agency, a fastener is a highly granular, microvariable asset.
Look at this 3D wireframe modeling a standard industrial bolt. When deconstructing a single part, customs agencies first divide it into distinct pathways, based entirely on its base material composition, separating steel from stainless and stainless from non-ferrous metals. Applying a specific chemical treatment, like a galvanized or plated coating, completely alters the part's regulatory profile, forcing the pathways to branch again. Micro-adjustments in threading specifications and physical dimensions add another exponential layer of regulatory branching. Finally, the intended end use of the part dictates its ultimate classification. A bolt engineered for construction architecture and an identical bolt engineered for aerospace fall into vastly different tax brackets. This extreme regulatory mapping is known as Harmonized Tariff Schedule, or HTS code granularity. HTS codes are standardized numerical systems used globally to classify traded products. A single error in this complex numerical mapping drastically changes the required duty rate applied at the border. Historically, the $800 de minimis exemption rendered this granular complexity completely irrelevant for small shipments. With the shield removed, this extreme underlying complexity is suddenly exposed to harsh, unforgiving regulatory scrutiny on every single shipment. The theoretical complexity of classifying a single bolt scales into an operational nightmare managing an entire high-volume procurement catalog. Procurement teams must navigate these precise HTS codes against dynamic layers of Section 301 and 232 tariffs. These are aggressive special duties imposed by the United States to protect domestic industries and national security, changing constantly based on geopolitical shifts. It is mathematically impossible for human compliance teams to manually process, research, and accurately classify thousands of individual SKUs at the speed required by modern supply chains. This risk flowchart outlines the mathematical reality. Manual misclassification frequently leads to overpayment at the border, resulting in silent, continuous margin erosion. The alternative is a severe operational risk. Underpayment triggers aggressive compliance audits and immediate customs holds. The sheer cost of resolving these customs penalties often far exceeds the physical value of the fastener order itself. A single misclassified SKU triggers a catastrophic domino effect. A customs delay holds up the part, which in turn halts entire highly synchronized production timelines. Treating fastener classification as a manual administrative task is an unscalable operational liability. It is a system that guarantees failure under the new regulatory volume. Surviving this aggressive, dynamic trade environment requires transitioning away from reactive shipping practices and building entirely compliance-driven supply chains. The required systemic solution is algorithmic classification, intelligent software capable of matching complex trade language directly to precise product specifications. This animation shows how modern platforms like QuickCode.ai operate. The software instantly ingests expansive, unclassified SKU catalogs and maps them into strict data streams without creating human bottlenecks. The system continuously cross-references and monitors tariff exposure across highly specific material composites and protective coatings. Instead of waiting for customs to flag an error, the platform delivers real-time alerts the exact moment global regulatory frameworks update. The software automates one final critical layer, identifying partner government agency or PGA requirements. These are strict regulations from agencies outside of standard customs, like the EPA or DOT, that must be met before a specific fastener application can legally ship. Algorithmic compliance provides the operational visibility required to adapt quickly, allowing logistics teams to maintain velocity without slowing down physical operations. As global trade faces increased scrutiny, modernizing compliance strategy is the only viable path to retain control. It ensures operations deliver the right parts at the exact right cost, completely eliminating margin loss from unmanaged tariff exposure.